Hey everyone, welcome. Let's jump right into today's explainer. We're tackling something that is literally keeping CTOs and engineering leads up at night, and that's AI token economics. We're going to look at how seemingly simple architectural choices can absolutely wreck your cloud bill. Because when you move from a basic chat interface to a complex agent workflow, your costs don't just scale linearly. No, they explode. So stick with me as we visualize exactly how and why this happens.
Real quick, here's our roadmap for the explainer. 1. The silent water leak. 2. Chat, the quadratic tax. 3. RAG, the retrieval tax. 4. Agents running the tap. 5. The $7 coding agent. And finally 6. Pricing the outcome. Let's get to it.
Okay, let's dive into this. Section 1. The silent water leak. Take a look at this quote from Paul Rengen. Most teams discover their AI bill the way you discover a leak, after the water damage. It is so spot on. Unlike traditional servers, you can't just right-size tokens or flip an off switch at 5 p.m. The meter never, ever sleeps. Tokens are consumed dynamically, they're priced asymmetrically, and they multiply silently. So most architects don't even realize they have a massive consumption problem until the financial water damage is already done and the bill arrives.
To really wrap our heads around this, I want us to use a pretty vivid analogy for the rest of this explainer. Think of it like this. A chatbot sips, RAG drinks, but an agent runs the tap. These are 3 totally distinct cost regimes. If you treat them all as just generic AI features on your roadmap, you are going to blow through your entire engineering budget faster than you can imagine.
Moving right along to Section 2, Chat, the quadratic tax.
The absolute most crucial thing to understand here is that a context window is not free memory. You've got to think of it more like a whiteboard that you rent. But there's a massive catch. You don't just rent it once. You actually have to re-rent the entire whiteboard edge to edge every single time you want to write a new sentence on it. In a conversation, every single turn means resending and rebilling the entire history.
So let's look at how this math actually plays out in a normal chat scenario. Say you have a conversation where each turn adds just 500 tokens. Turn 1? Harmless, just 500 tokens. But by turn 10, you're sending 5,000 tokens for that one single call. Your app is paying to reread everything. Fast forward to turn 40, suddenly your input is 20,000 tokens per turn. The costs aren't growing in a straight line. They're compounding quadratically, totally under the radar.
And here's the crazy punchline. That 40-turn conversation, adding just 500 tokens at a time, silently compounds to roughly 410,000 cumulative tokens. You literally end up paying for 20 times the size of your final context window. It's this compounding effect, not necessarily one single massive call, that acts as the quiet engine behind almost all surprise AI bills.
And this brilliantly illustrates our next point. Section 3, RAG, the retrieval tax.
So if chat sips, RAG drinks. Heavy. RAG introduces what's known as the rereading tax. Every single time a user asks a query, the system goes out, grabs relevant chunks of data, and stuffs them into the context window. You are paying over and over again to process long prompts, the chat history, and all those newly retrieved chunks. Plus, you have the hidden costs of generating embeddings and re-ranking. And honestly, if your chunking strategy is even a little bit sloppy, you can easily triple this tax without getting a better answer.
Which brings us to the deep end, Section 4, Agents running the tap.
Now, what's really interesting about this visual is the staggering difference in scale. Chat is just a tiny blip up there, maybe 1 to 3,000 tokens in exchange. RAG is sitting in the middle at 5 to 15,000 tokens a query. But agent workloads, whole different ballgame. They demand 50,000 to well over 100,000 tokens per task. It is a completely different architectural regime, no question.
So why on earth is the agent bar so huge? Well, because an agent runs a loop. It makes a plan, calls a tool, reads the result, thinks about it, and repeats. And remember our whiteboard analogy? Every single time it loops, it has to reread the ever-growing transcript of everything it just did. What looks like a super routine 10-step task to a human developer will relentlessly consume between 50,000 and 100,000 tokens. Easy.
All right, let's look at the absolute extreme. Section 5, the $7 coding agent. $7. I want that to sink in for a second. That is the cost a single session from a coding agent like Claude Code or Cursor can exceed before anyone even logs in to check a dashboard.
Just one single multi-step developer session, making a couple hundred calls against a frontier model, can rack up a $7 bill. That is an order of magnitude beyond any standard chat session, and it happens in the blink of an eye.
How? Because coding agents are silently stacking 4 different bills at once. First, large context. They load entire repositories and multiple files right out of the gate. Second, long loops. We're talking dozens to hundreds of individual calls per session. Third, verbose tool output. They're pulling in massive build logs and test ups. And fourth, reasoning is turned on by default, meaning all those hidden deliberation tokens are billed as expensive output. Put simply, an agent without a strict maximum step count is an unbounded liability for your business.
Let's move to our final piece and see how this builds into strategy. Section 6. Pricing the outcome. As an architect or a CTO dealing with this kind of scale, you really have to shift your mental model to stay grounded. There is a huge disconnect between cost per token, which is basically just what the engineering meter says, and cost per outcome, which is what the business actually cares about. Nobody's CFO thinks in tokens, right? The executive room thinks pragmatically in resolved tickets, successful bookings, and merged pull requests.
I absolutely love this analogy from the source material. A factory doesn't optimize for cost per kilowatt hour as its KPI, it optimizes for the cost per widget produced. For AI, tokens are just your electricity. The true metric you need to be optimizing for is goodput. That's the cost of tokens produced at the exact quality level your application actually requires. Because think about it, if a cheap model fails 30% of the time and you have to escalate to a human, it might have way worse goodput economics than a model that costs 3 times as much per token.
So what does this all mean? I want to leave you with a pretty provocative thought. Because token prices are constantly falling, Jevons paradox is kicking in. Cheaper tokens don't mean lower bills, they just make infinitely more complex use cases viable. Agents will multiply your consumption much, much faster than prices decay. If you are selling an AI product priced per seat, but you've got unbounded agent usage running underneath, you are effectively writing an uncapped call option against your own business. So is your application one of them? It might be time to audit your systems and get some strict token governance in place before the water damage sets in. Thanks so much for joining me on this explainer, and happy building.